Hi everyone, welcome to today's class. Today we are going to discuss about what are the TCP options. We are going to look at what are the TCP options we have, and we'll see how the sequence number and acknowledgement number works in TCP. And then we'll look at what exactly the retransmissions and how we can filter the retransmissions. Followed by that, we'll look into what is FIN and resets. Fins and resets are the flags in TCP. So we'll go in detail about that. So to start with, let me go with the TCP options, and I'll give an overview about the TCP connection establishment. We discussed about the TCP connection establishment before last week. In the last class we discussed about how this TCP SYNAC and ACK works. We didn't go deep about that. So today's class is more with what are the TCP options we have. So let me start with TCP options first. So if you look at this, so selective acknowledgement. Selective acknowledgement is something we got, we know this connection establishment. So let me open the paint to be much helpful to explain better. Okay. So let me make this sender and receiver. And we know the three-way handshake. So the first packet is SYN. This is SYNAC from the receiver. And finally ACK. So this is the sender and this is the receiver. And we say this is connection oriented protocol. And we got 4 tuple connection, right? The first thing is source IP, source port. And this is destination IP address and destination port. So 4 tuple connection, source IP, destination IP, source port, destination port. So 4 parameters involved here. And this is connection oriented. So we know about that. So once this has successfully happened, and once this connection establishment is successful, once a connection establishment is successful, only then the TCP will share about this TCP options. So imagine we got 10 gig link fat pipe that goes inside the ocean. And back in 1981, 1980s, where this TCP was emerging and TCP exists, we do not have an option like TCP options. That is pretty simple, I would say. So window size is a buffer. The amount of data what I can hold. Maximum data I can hold. So that is 65,535 bytes. This is a maximum, but if I got a fat 10 gig link, as I said, if the sender is sending more data, is transmitting more data, so how do I going to receive that? So to overcome this challenge, they introduce the TCP options. And for this TCP option, if the TCP option should work, then both end has to synchronize with same TCP options. It has to be enabled and supported on both ends. So that is one parameter of the very important parameter of TCP option is selective acknowledgement. We'll go one by one. So I'm just listing out all the options we have. So this comes under TCP options. So why this is important? Because when you do a troubleshooting, you should know what is TCP selective acknowledgement. So only then you can figure out where exactly I'm losing this TCP stream. So now let me open the Wireshark and let me show you what is TCP selection acknowledgement. So if you look at this, this is my very first packet from the source to destination. And this is a client. So this is a client. And this is a server. So the very first packet here is a SYN packet. And for the SYN, I get a SYNAC. For the very first SYN packet, what are the TCP options I have? So to do that, you have to drill down this transmission control protocol TCP, and you can see the list of options here. So I support the maximum segment size is 1460 bytes. That's the maximum I can hold. And this window scale, you have to multiply the window scale by 4. So now what is my window size? It's 8192, and you have to multiply this value by 4. That is the maximum. So to put it across in a very simple perspective, let's say 1 gig is my maximum data I can receive. That's the advertisement it does during the SYN. When I'm sending a SYN to the destination, I'm saying my maximum segment size is 1460 bytes, and my window size is 8192 bytes, and you can multiply by 4, and the maximum is 1 gig is my maximum across the world. So this is a maximum amount of data I can hold. And the other thing we discussed about the very key parameters we use in the TCP options are maximum segment size, then SAC. So it should be always the SAC should be permitted on both ends. Only then this options will work. Why this TCP options? No, that's been evolved and enhanced just because to hold up more data, because now the network is growing fast and we have got 10 gig fat pipe under the ocean, and I cannot work with the normal TCP window, a minimum window size value. So they evolved and they created all this, the TCP options. And coming to SAC, what is selective acknowledgement? I'll tell you. See, example, if I got my communication happening like this, so SAC, as I told, it has to be enabled on both ends, only then it works. So if you go back here, even I see SAC is permitted on the destination. This is a destination here. And this is a source. So it's enabled on both ends, client and server. So this is a key thing you should look at when you look for the SAC, selective acknowledgement field parameters in TCP. So I got it. So it's a successful TCP handshake happened. Since SYNAC ACK, I'm successful, so I'm ready to send a data. So the protocol used here is HTTP. So if you drill down and if you actually see this, all this black coloring rules, this is all your bad TCP. There is something happened here. So it could be a network problem or it can be an application issue, but how do I find that? So here comes the selective acknowledgement. If you look at here, it says the selective acknowledgement says the sequence number 59861 to 61321. I'm missing some packets between 59861 and 61321. There's some packets that's missing in the middle between 59861 and 65321. And now here comes what is duplicate acknowledgement. So Wireshark is very intelligent to figure out that if you actually see, it says a packet number 53. Use a different color here. So packet number 53, exactly here. My TCP communication happened successfully here, but it says TCP previous segment not captured. So I am missing some packet. I'm missing a segment of packet. Example here, if you got multiple segments like this 1, 2, 3, 4, this is the range 593, 59861 and 61321. So example, this is 59321. Sorry, 59861 between 61321. So I'm missing a packet between these two. And it says it's a duplicate acknowledgement because I acknowledge this back. So here I see all this acknowledgements here, right? And how I did that here, I have to go to TCP, and you should always look at the relative sequence number. So the three fields is very important. So sequence number, relative sequence number, relative acknowledgement number, and the next sequence number. So these are the three fields I have added here. I'll tell you why we need that. So how do I make this as a filter here? I'll show you that. So you have to click on it, right click, and we discussed in the previous classes, so you can apply as a column. I did that exactly. And since I'm adding more fields, I'm adding more information in the Wireshark, so it has to be very compactable from my screen layout. So what I did is you have to right click on it and you have to click on edit column and you can change the name. I change this name. So by default, it will give us an acknowledgement and you can change your value here. And if you click OK, that's going to save your filter here. So I did the same thing for everything. So I went to sequence number, relative sequence number, not raw sequence number. Always the Wireshark is interested in, we look at only the relative sequence number for troubleshooting. So I have to right click, apply as a column. Once it is applied, it will be applied as a column, and you have to click on the particular column and you should edit and you can change the value here. I just renamed. I didn't do anything else, only that. So it says this particular acknowledgement 46721. Right, it says packet number 53. If you see the acknowledgement number here, I have already acknowledged 46721. But I am doing this acknowledgement again, where the source is saying So I'm acknowledging it back again. If you actually see this 53#2, it's that I have already acknowledged 46721, but I'm again doing an acknowledgement because why? I am missing a packet after 46721. So this is how you can find, when you see black filters and the TCP, bad TCP, you have to figure out. And here in the selective acknowledgement option, you come to know what exact stream I'm missing. So this is important to know for selective acknowledgement here. So this is how the selective acknowledgement works. So I missed this particular segment. So I'm not doing a retransmission for the whole process. Example, see, I send a SYN and I get a SYNAC back and I acknowledge, right? SYN, SYNAC, and ACK. The connection established successfully. Then coming back to the paint. So this connection establishment happened successfully and my TCP streams is going on between source and destination. So in this particular TCP streams, one particular segment, I'm losing a segment example. Let me number this as this is a sequence number 1456. So the sequence generated by the Wireshark, right? Sequence number 5678. So it's saying I'm missing the sequence number between 1456 and 5678. So instead of the whole process, what happens if there is no selective acknowledgement? It has to do a retransmission for the whole process from beginning. From beginning, it has to do the retransmission from top to bottom. So instead of that, I am missing out only one particular segment. So I want that to be retransmitted back. So Wireshark going to show you that. So previous segment not captured, and it is sending a duplicate acknowledgement again. So if you see here again, the client is sending duplicate acknowledgement because I'm not receiving any data after this. After 4672, I'm not getting a data. But if you see here, again, the sequence number is 46721. And along with this data, if you add, you will get 4818. So it's retransmitting the data. So this is my payload 1460 plus the sequence number 46721, and you will get this value. So my next sequence number is 4818. So it is retransmitting back. If you look at this all duplicate acknowledgements sent from the client to the server. And now again, the server is sending back the retransmission. I'm retransmitting this data because you missed this data. So I'm doing a retransmission here. So this is how the retransmission works here. So now we should know, okay, what is fast retransmission and what is a duplicate acknowledgement, what is TCP out of order. So if you see a lot of these packets, then there is a problem with the network. But if it is minimal and if the retransmission happens and if you see the FIN packet, your communication is successful. To filter this communication is successful, we have a filter to find about FIN. And before that, I'll give you a glimpse about what exactly the FIN is. So if I see a lot of retransmissions, it's keep happening, right? That should be the, depends on the circumstances. There is a circumstances you see a lot of retransmission, then there is a problem with the packet loss, network issues, it's not responding. So we have a lab, so we'll see how this retransmission happens and how this FIN works. But I'm giving an overview about what is retransmission. So this is something see if you see this particular server keeps sending a data here. And there is a point where exactly you can see, hey, my window is full. The server says my window is full. You don't send any data. You wait for some time. So after some time, again, the server is retransmitting because you requested for some segments and I was busy. My TCP window is full. I'm full. My window size, see, if you see this is the window size and my window is full. I cannot hold up any more data beyond this. So that's the meaning of TCP window full. So my window is full. You cannot send any more data. You have to wait. And after that, it is again retransmitting. So when there is a problem happens with slowness or irrespective of an applications or whatever it is, but you have to check this. Who is doing the retransmission? Is it the client or server? So that is a key thing to understand where the problem is. Now the server window is full. It is processing some other client's data and it is full and it's asking the client, hey, wait for some time. I will retransmit your data. So if the retransmission happens and if you see the fin packet, then yes, my communication is successfully happened and I finished my exchange. So there comes the fin and reset. I'll tell you the key difference between fin and reset. So here the communication is keep happening. I send the data, I receive an acknowledgement, I am keep sending other sequence of data and getting an acknowledgement back. So what if my connection is completely successful? If my connection is successful between source and destination, let me put this across. So my connection is successful here. I received all the data. So at this point, okay, I received all the data. The source is saying, okay, this is source and this is a destination. And destination, this is source. Connection successful. I received all the data. So finally, both end will say gracefully, let's close the connection is called fin. Let's finish this conversation. I received all the data, whatever you sent, I received it. So let's close this connection. That is fin flag. Reset. Example, if I try to establish a connection on port with the port number 2356, a random port, and the destination is something, a random port 4567, and I'm blocking this port. So what happens? I'm not ready to listen on port 4567. I'm not going to respond on this. So what happens here? So here happens the reset. Who is going to reset? The destination is going to reset this. I'm going to reset your connection. I cannot accept your connection on port 4567 because that is blocked. And you're doing some malicious thing. You're doing scanning. You're trying to intrude my connection. So I'm not interested to respond back. So that is abruptly, if you disconnect, it is a reset. And fin is both end. Both are gracefully closing the connection. Hey, I am good. You're good. So we are closing the connection. That's a graceful shutdown or gracefully closing the connection. So this is all about reset, fin, selective acknowledgement. So what we discussed here. So we discussed about 4 tuple connection. We discussed about what is SYNAC, ACK, and what are the TCP options and what are the parameters inside the TCP option. The main option is maximum segment size and the selective acknowledgement option. So what is the amount of data I receive, where I miss? And we discussed about what is duplicate acknowledgement and what is previous segment not captured, what is meaning of it, where the problem is. So how Wireshark is interpreting all these values, we looked at that. So now going forward, so this is all about this TCP selective acknowledgement and the options available with TCP retransmission and previous segment not found. So now let's move forward with the next topic. So how sequence and acknowledgement number works. So let me open up the Wireshark for it. And you have to make a filter exactly like this. These three filters are very important. TCP segment length. You can see here TCP segment length and sequence number, next sequence number, and acknowledgement number. So you have to keep your next sequence number next to sequence number. That's how you can, compare. So now let's discuss about how this sequence number and acknowledgement number works. So here, this is a very first packet, SYN packet. So I send a SYN and my next sequence number is 1. So from here, I didn't send any data. I didn't send any payload. This is just an connection establishment and my TTL is 0. So nothing is happening here at this point. And the acknowledgement, this is called a ghost bit by Wireshark. This is happening, but no real acknowledgement is happening at this point. So for this SYN, it is sending a SYNAC back. If you look at the sequence number 0, and the next sequence number is 0, and acknowledgement is 1. This is just to say I accepted your SYN and I'm okay with your SYN. I am going to send you SYNAC back. And exactly here, no data is exchanged. Only these fields are called ghost bits. So you don't want to consider until this point. So you have to check only SYN SYNAC ACK. It's successful. And you can compare the fields inside the TCP flags. Acknowledgement bit set. And if you look at this SYN ACK, both SYN and acknowledgement bit set. This is all ghost bits. No actual data communication is happening here. So when you look at here, exactly here in HTTP, we send a data of 324 bytes of data. We send this. And what is my next sequence number? 325. So what it says, I got 325 and then I acknowledge 325. It's that, okay, you send a data of 324 plus the next sequence number 1, that is 325. That's how it works. Your TCP segment length with sequence number 1, it becomes 325, and I acknowledge 325. It means that, okay, I got this data and I'm sending an acknowledgement back. And if you actually see this, this is a sequence number of 1460. And the next sequence number is 1461. So if you see here, the next sequence number is 1461. So this is how the sequence number and acknowledgement number works. So sequence number is nothing but it's a combination of values. Example here, see if I got a value, this is the payload 324 plus 1, and I get an acknowledgement for 325. It means that I add 1 to my actual payload, that becomes my sequence number, and I get an acknowledgement back. So this is how the sequence number and acknowledgement number works, and you should look at what exactly is missing. So because if you see this, if you see the bad TCP packets, you will understand better. So let's take this example. So it says previous segment not captured, and it is acknowledging for 325. Where is 325 here? Already packet number 53, the Wireshark is going to give you this option. So all my TCP streams has been successfully sent between source and destination. This little tick mark here, it says on packet 52, I offloaded all this traffic, whatever the receiver wants. here the connection is successful. So here says it's a duplicate acknowledgement. Why? Because the previous segment not captured. So it acknowledges for 325, but it is missing out some data. And here exactly the retransmission happens here. If you see this, this is the next sequence number 46721. So it is retransmitted here. You can correlate this values here. So the next sequence number, it is missing here. And if you actually see, that's been sent from the server to source here exactly. So this, if you understand the sequence numbers, how it works, you can figure out where exactly retransmission happens, which set of data I am missing out exactly. And you can compare the values here. If I go to TCP duplicate acknowledgement, if it says 59861261321, I'm missing some packets. The missing packets, it is retransmitting it back. So this is how the sequence number and acknowledgement number works. You have to do your own capture. If you keep practicing, you'll understand exactly how to compare and where to find the issues. So this is all about how sequence number and acknowledgement works. We know about that. Now we'll look at closer look at retransmission. We saw okay, I'll show you what is fin and resets. I have a capture for it. Let me open fin and reset capture. Let me close this. So let me open up this capture. So this is very simple filter you can apply to only to figure out the resets in TCP. TCP.flags.reset equal 1. So here it says out of 32 packets, the displayed value is 0. So I don't see any reset in this capture. So here exactly I see resets. That is abruptly disconnecting. So not a gracefully closing this connection. So to follow this stream, let me go to conversation filter, TCP. So no much data is exchanged. If you see, no much data is exchanged. So this is a source and destination, and vice versa. I send a SYN, and this destination is not interested, and you want to talk to me on port 80, and I don't want to respond you back. So it's abruptly disconnecting. That is reset. No much conversation happened here between source and destination. If you see how I'm saying this, because if you see this value TCP segment and 0, no much data is exchanged. It is just sending a SYN. It's sending no reset. I'm not interested to respond back on this my port 80, and I don't want to establish a connection there. So I'm going to reset this connection. So if my TCP connection is not established, so I cannot send any data, all my connections are dropped. The first thumb rule is you have to establish a successful connection. Only then your actual data transfer happens to you from this point. So this is about TCP reset. We'll do a lab for TCP fin retransmissions. So let's take a closer look on what is TCP retransmission, how it happens. So I'll explain this topology, what I did exactly here, no big thing. So I got a router here. I got a switch. Both are layer 3. So I can assign an IP address to it. So this is just a PC for testing. So what I did, I have configured the IP details. I'll show you. Pretty simple, just a point-to-point connection. I assigned an IP address as 10.0.0.2 10.0.0.2 on fast Ethernet 0/0 here. I assigned this IP address 10.0.0.2 and fast Ethernet 0/0. If I go to Ethernet switch 1, show IP interface brief. So I assigned 10.0.0.1 on fast Ethernet 0/0. So this is a point-to-point connection. Point-to-point connection between source and destination. So I have to check the basic testing. So can I ping 10.0.0.1? 10.0.0.1. Yes, I can ping. This is my loopback 10.0.0.1. What is my IP here? Show IP interface brief. Again Ethernet switch and 10.0.0.2. From here, let me ping 10.0.0.2. Nothing much, same the default CIDR value I have used. Same subnet mask, CIDR 255.0.0.0/8. And I have created an ACL. What is that? Show IP access list. So here I created, whenever I see FIN packet, log this information in the ACL. And we can see that in Wireshark. So all other traffic is permitted. If you're not permitting this, this is a default deny. So you have to permit TCP and you have to allow your IP traffic. Only then your IP communication happens. So that's it about the ACL, very simple. So I want to log the traffic for FIN packet. That's the objective of this lab. And along with that, we'll see in the same lab how this retransmission happens and how it happens and what is the sequence number and how it recovers from it. So this is all about the config here. And if I go to PC1, here I created a gateway here. I created a gateway show IP interface brief to check a connection here. 30.0.0.1 fast Ethernet 0/1. So the gateway is configured as 30.0.0.1 here. So this PC is .3, 30.0.0.3. Can go to this PC and I'll show you what is this. You can give a question mark and you can see the commands what you can run. If I give show IP, so it says okay 30.0.0.3 and /8 and my gateway is 30.0.0.1. And this is a MAC address and this is a default MTU 1500 bytes. So this is all the simple config I got here. So from here I can ping 30.0.0.1. I'm just trying to check all my basic connections are good. Yeah, I get ICMP response back. So my connection is good. So now let's generate some traffic. So now I'm on router 1 and I enabled Telnet because it uses TCP. Show run include VTY. Should. Okay, so let me give show run. Okay, so line VTY 024, so total 5 connections and the password is Cisco. This is the config I have with Ethernet switch 1. So from this router, I'm trying to establish a connection, Telnet connection, and it is using a TCP. Let's see what happens. So let me stop the capture. So I'm establishing a connection from this device to this switch, and I am using Telnet. Right. So let me open up this putty session, and I'm going to do Telnet 10.0.0.1. So before that, let me start the capture here. Start capture from fast Ethernet 0/0 to fast Ethernet 0/0 on the red switch to the router. Let me close all this. Start Wireshark. Okay, say it says port ID 0/0. Okay, I'm fine. Now let's go back to the router 1. And now I'm trying to establish a telnet connection. Telnet 10.0.0.1. And if I give a password, Cisco, enable Cisco, I did that. So now I exit a connection. I exit from the source. I'm done. Now stop the capture. If you actually see here from the beginning, so it says acknowledgement 11. So I send an acknowledgement on packet number 11. I send an acknowledgement and it is a duplicate acknowledgement. If you see both acknowledgement is one, it's a duplicate acknowledgement. Wireshark says it's packet number 11 duplicate acknowledgement. And once this successful connection, say since SYNAC ACK, your actual TCP, your actual telnet data is going through after this three-way handshake. And as we discussed, it's a 4 tuple connection: source IP, destination IP, and source port and destination port, 4 values. So I'm done. So my connection established successfully. So what's next? So here exactly I'm trying to use a telnet. My TCP stream is going well and I see acknowledgement back. I send a next set of sequence of data. Here you see the payload is 12 and here the payload is 42 and 42 plus 13 and you get the value here 55. The next sequence number is because I got this and I acknowledge this. I send this, I got this data and I acknowledge this back and I received it. So I see my all this communication happening smoothly. I'm good. So what happened exactly here? Until this point, I pressed and typed some commands and my telnet data is keep happening. And this point, if you actually see 10.0.0.1 is the destination. If you look at the IP details here, show IP interface brief, it's 10.0.0.1. So 10.0.0.1 says, hey, we are good. You're done with that. So I'm going to send this fin. Let's close down this connection because you're done. You want to close this connection. So once you close the connection, I'll also close my connection here. This is 10.0.0.2. This is a source where I initiated the traffic. I give show IP interface brief 10.0.0.2. So you also send a fin and I also send a fin. My connection flows smoothly. No TCP errors at all. If you see duplicate acknowledgement, if you see this black packets, one or two, and it depends on the circumstances, as I said, if it is more and if you are losing more data, then you have to look at this. But at this circumstance, this particular scenario, I have a successful connection. Both send a fin. I'm good. So the takeaway is how I can analyze and how what we should know about how sequence number works, how acknowledgement number works, what is duplicate acknowledgement, what is fin. So all this are vital data you should know about when you do a troubleshooting. So this is a successful connection. I see fin. That's good. So in the same way, how this switch is actually looking at this packet. What is the maximum details I can see from the switch? If I give, if you actually see, this is because I enabled a log and it says the traffic is coming from 10.0.0.2 on port 23 telnet, one packet. Yes. So this is this particular ACL is for fin. So 5 matches. So this is only information I can see, but in the Wireshark, I can see, okay, what is the acknowledgement number? What is the source number? And where exactly the fin is happening. See, I see all the streams, all this data is successfully exchanged, right? I'm not missing any TCP packets here. You do not see all this in the router, right? So I see the successful communication for all this sequence number. So my data transfer is happening very smoothly and we are closing a connection. This is a gracefully closing the connection without any errors. But this is going to just show you, okay, do I see the fin packet? Yes, only that information. You do not have a granular control over all your packets, whatever you see. But in Wireshark, you can see all this details here. And if you go and check here, the selective acknowledgement, as I told, see, this is here in the selective acknowledgement, there is no missing packet, so I don't see anything here. And if you look at here, I see only the window scaling factor, flags. I don't see the options here other than the window scaling factor. So here no window scaling is used because if you look at the actual data, whatever I sent here, it is below 4128. So all are 3 bytes, 2 bytes, 560 bytes. That's the maximum payload I have here. It's not used. So it depends on the circumstances where you use that. And if you click on the left corner here, you can see all these details. So connection fin packets. If you right click, apply as a filter, you see only the fin packet. So from source to destination, I see fin. From destination to source, I see fin packet. So, okay, I got a confidence. Okay, my connection has successfully happened and both close the connection successfully. And I see SINAC from the server, because the port 23 to the source port, random port, and maximum segment length 1460 and the window size 4128. Do I see duplicate acknowledgement? This is bad. Yes, I see only one duplicate acknowledgement. And this is from the client to the device. From looking at the port number, I know, and this is the window size. And it is using TCP. So this is just very helpful. If you want to apply this as a filter, select this and you see only the duplicate acknowledgement. TCP.analysis.duplicate.acknowledgement. So you cannot remember all this filter, but you can make use of this Wireshark export information. From that, you can make your own filters like this. You can right click, select, and it will be applied as a filter. So now let's see how retransmission happens. For that, let me go back here. So now let me stop the capture. Stop capture. So go back to router 1. Let me configure. Let's initiate a TCP connection again. Start capture. Okay. So I short loads. It fired up, so I can see packets going on. Let me go back to R1 Telnet 10001. Let me press up arrow. I'll get, yeah. Telnet 10001. So I give the password, enable, again password. I'm on the prompt. So the traffic is still going on. You do not see any fin packet because I didn't finish the connection. So apparently I should not see fin packet now. Now let's go to this device. Show IP interface. Let me do it here. Show IP interface brief. Configure. And I'm going to shut down this port. So now shut down. And let's see what's happening here. So I lost access to it. And if you see here, 10002, my source router keeps sending retransmissions. Hey server, you're not receiving my data. I'm keep sending the packet back again and again. I'm sending retransmissions. This amount of data it sends, 6 bytes, and keep sending retransmissions. So if I go back to switch 1 and if I give no shutdown, exit, exit. So now I should not see any more retransmission happening here. If you see who is sending a retransmission, that is important. So my source 10002, my router is retransmitting to this destination Ethernet switch. Sorry for that. This is my Ethernet switch. So now I know, okay, I'm sending a retransmission. The destination is not responding back, so I keep sending a retransmission again and again and again. So once this is done, I get an acknowledgement back. Again, my telnet data is sent from source to destination, destination to source. So this is how the retransmission works in real time. And when you see retransmission, you should see where exactly the retransmission is happening, who is retransmitting the data. So that is important here. So that's it about TCP retransmissions. And we saw what is resets and what is fin, and we did a lab for it. And we discussed about how to apply the filter for reset, how this is a filter for fin packets. And now we'll see a use case for, there is a problem with the client. So, I mean, there is a scenario where we have a problem and we are going to find, is it a problem with the client or it's a problem with the server? This is a use case. So I'll open up a Wireshark for it. Okay. Let me close this. So the very first thing is I have to go to the expert info here. So I see, I mean, this is really huge out of order. So I'll tell you. So this is very important. I'll go back to this paint. Let me delete this. This is source and destination, and I'm just making this synac ack. The source. This is destination. So the key parameters we should look at. Let me show you this. Let me take this. So TCP retransmission. TCP retransmission, out of order packets, duplicate acknowledgement. This all proves we have a problem with network. But as I told you, it depends on the circumstance. If I see that in the minimal, that's okay, that's because of a latency. There is a device in the middle or maybe a destination is not processing the data and it has a link issue because the link got choked up. But if there is a continuous retransmission, if you see a lot of out of order packets and duplicate acknowledgement, then definitely it's a network issue. Then based on the circumstances, you have to figure out, as we looked at the retransmission with the lab analysis, we come to know who is sending a retransmission. So it is because of interface, the IP communication is not happening because the point-to-point connection was down. So it keep retransmitting the data to send it back. So it is a problem with the destination. So based on this, on the circumstances, you have to figure out where exactly the problem is. So, but the biggest takeaway is how we're going to find it. If we know the basics and if we know how it exactly works, you can figure out in any complex network, you can figure out where could be where the problem actually exists. So now coming to this, how I can filter out the bad TCP connections. So if somebody says, okay, so I have some problem, the server is not responding or it's a client not responding, the very first call I would take is, okay, first let me open the packet capture. Send me a packet capture here. Let's open up the packet capture. Okay, let's see the very first packet, synac ack. So the time value is the key crucial thing when I always look at. So here it takes 3 seconds. takes 3 seconds. After this dotted decimal, the right hand side, it is milliseconds. And if it is the left hand side, it is seconds. We discussed about that. So it takes 3 seconds to send a SYN. Some Dropbox communication is happening, and here exactly the TCP communication happens, and all goes well here. And this is based looking at this protocol SMB. This is a file share. You can see that this is a shared folder. It's trying to access, and it is trying to copy a file. So I should look at all this. Okay, I established a TCP connection. So what's next? So it's my file share. So I'm trying to download some file. It's a file transfer happened between source and destination. And this is a client. And this is a server. And let me drill down here. So if I go for any bad TCP packets, I see duplicate acknowledgement here. Let me apply as a filter, selected. I keep sending this duplicate acknowledgement. So packet number 1024. So let me close this. Go to packet number 1024. So after this, exactly, I see this duplicate acknowledgement. It says I already acknowledged this 9042. Can you see this 9042? Already acknowledged this. If you see here, but still I'm sending an acknowledgement because I am missing out some data here. But here is the main thing. See, if there is a duplicate acknowledgement, the very first thing my eyes always goes to this time filter. If you see the actual communication, the round trip time, RTT, we say RTT from source to destination, destination to source. It's very, very minimal. It's happening in 25 milliseconds. It's happening in 134 milliseconds, 101 milliseconds. It's not even going to seconds. So it's definitely, see, this is all TCP duplicate acknowledgement. The client is sending back to the server. So what are the other things I have to look at? If you see, there is continuous data and you have to compare side by side. Is it my time values increasing? No, but the client is keep sending the duplicate acknowledgement again and again because I didn't receive this packet. And if you drill down, I see the client is keep sending a duplicate acknowledgements. I keep sending a duplicate acknowledgement. You have to go through the complete capture. So let's see the fin packet. If I see the fin packet, the connection establishment is fine. TCP.flags.fin equals 1. If it is true, it should show me the fin packet. So it says the displayed value, no fin packet here. So the communication is broken in the middle. The complete communication is not happening and the client keeps sending this duplicate acknowledgements. I am not receiving your data. So if you see the out of order packet, duplicate acknowledgement packet. As I told, this all interrelated. So if you see a lot of duplicate acknowledgement, a lot of TCP out of order, but there is no problem in the network. It is something problem with the application. It is because of the server or this particular application 10002 has a problem. It has a problem. So we have to look at this server, this particular application, why it is not happening. So I'm missing a lot of data because of the server, not because of the client, because I see all this black packets. It's keep the client sending back to the server. The server is not sending back anything. So this is a use case. You can make use of it and you can see the retransmission. So do you see any retransmissions here? TCP.analysis.retransmission. So the server is sending a retransmission. Again, if I follow this filter, conversation filter TCP, duplicate acknowledgement, and for the missing packet, the server is sending back again, but not a lot of retransmission. That is important. So I see hardly one or two retransmission from the server, but from the client, I see a lot of duplicate acknowledgement, a lot of TCP out of order. So what exactly the out of order says? See, I'm missing out some data in the middle. The segment, whatever I'm receiving, I'm missing in the middle. As I told, I got a check of, I got, the sequence number, acknowledgement number, and that my TCP stream is happening very well. But in the middle of something, I'm losing a packet between 1056012 and 1057472. So definitely this is a problem with a server. And the very first thing when you look at the network issues, you have always look at this time value. Is it my round trip time? Because see, from source to destination, destination to source, how long it takes. This is my source and this is my destination. And what is the time taken here to send and receive? Round trip from source to destination, from destination to source. It looks good. I do not see any problem here. So I'll give you one more use case for a retransmission. So example, I got a device like this. I got a switch. So I got two devices connected like this. This is a use case where I experienced a problem with, and this is a voice device, voice gateway. And this is a Nexus switch, 7K. And we got a connection like this. So this is a firewall. And this is a firewall. And this is a Cisco device. And this is a Palo Alto. So example here. So the layer 3 is on both device. So let's take a segment 167.0.0.1/8. Let's make this as 167.0.0/24. So I got this. So 8, it means the first octet, the first port. And here, so it matches on both. So this particular SPC has been assigned, sorry, this voice gateway has been assigned with 167.0.0.5/8. The communication between the switch and the firewall is just a layer 2. Both use the same VLAN. Example, VLAN 800. Here also I'm using VLAN 800. So from the switch perspective, it's one layer. It's only a layer 2. This particular SPC is configured with VLAN 800 access port. And on this particular interface, I assigned this IP address, this voice gateway. So when we had a problem, when we did a capture on this voice gateway, and we see a lot of TCP retransmissions. from 167.0.0.5 is sending a lot of retransmissions. To a public IP. Example, let's take, let me take this 8888. So what is the real problem here? So the traffic coming from this switch, it has to go to this firewall, and this is an outside interface. And it has to go to the internet. A lot of retransmission is happening, but when we looked at exactly the retransmission packet, example, this is not a retransmission packet. So when I exactly look at the retransmission, if I go to retransmission, in the layer 2, I do see here this particular destination MAC address, it was showing for Palo Alto. But it is supposed to be an ASA Cisco firewall. So from the SBC capture, we found, okay, the traffic is actually, it is destined for ASA. Actually, it is destined for ASA. It has to go this path, but instead it's going through this. This is correct. So it is going here. But the actual path, it has to go through this path. So only with the layer 2 header in the retransmitted packet, the layer 2 header, you can see that. So because my heart suggestion is to, you have to look at in every field and you have to compare. You cannot just compare with retransmission. You can figure out, okay, this is the problem with the source and destination. You have to go through everything, every possible ways, and it is based on the circumstances. You have to apply the logic and we have to figure out. So this is about TCP retransmission and the use cases we discussed. And when you actually see this black package, it's really a bad TCP. And the filter, you should always use, the very best filter is TCP.analysis flag. Along with that, you can also use Wireshark expert info. Both gives the same output. You can see all your bad TCP. TCP.analysis.flag, very useful filter. And if you want to apply this particular filter, you can add, and you can apply this as a filter, your own filter. If you want to make it as bad TCP. So whenever I look at any packets, if I just click on bad TCP, it's going to show up this. This is how you can apply your own filters. So you can do your own capture and you can try to answer these questions with your own capture, so you'll understand. And if you have any questions on that, you can ask me. So let me put this in the chat for everyone. Set. Okay, I'll put this the chat. So the final the final thing we'll discuss about the use case for a trace route. I found this is quite interesting. So I want to share this. And if we discussed about all this time to leave exceed and how TTL works. But here from source to destination, what is the number of hops? So if I try to make it with 4 hops, I'm not reaching the destination. If I make it with a 5 hops, I can reach the destination. You can see all this TTL is 5 hops. So if somebody asks a question and somebody you have any problem with your latency, and you can very well you can concretely you can say, okay, I am 5 hops away from this source to destination. This 5 hops. The very end of this packet, you can see that information. I found this is useful. And if you look at this, it uses UDP. It can be a Linux box. It can be a Cisco device. So the main key thing here is what we have to look at here. So from my source to destination is 5 hops. And if you do same PCAP on this destination 172.16.0.2, you'll get to know how many hops away is 10.0.0, 10.0.1.2. So how many hops away is my destination? So this is all about for today's class. This is a capture we are taken from this MPLS connection and to find the number of hops. If there is a question, so how to find the number of hops from source to destination in the end of the packet, you can see here the number of hops is 5.